Infusion pump. An infusion pump is a medical device that delivers fluids, such as nutrients and medicaments, into a fine body in controlled amount. Infusion pumps are in widespread use in clinical settings such as hospital, nursing homes, and in the home. In general, a infusion pump is operated by trained user who programs the rate and duration or fluid delivery time involved in software interface. Infusion pumps offer significant advantage over manual administration of fluids, including the ability to deliver fluids in very small volumes and the ability to deliver fluids and precisely program rates or automate intervals. They can deliver nutrients or medicaments such as insulin or other hormones, antibiotics, me drugs, and pain deliverers. There are many types of infusion pump, include peristaltic infusion pumps. A peristaltic pump is a type of positive displacement pump used for pumping a variety of fluids. The fluid is contained with a flexible tube fitted inside a circular pump, causing two linear peristaltic pumps have been made. A rotor with a number of rollers, chosen with zipper or lobes, attached to external circumference of the rotor compresses the flexible tube as the rotor turns to part of the tube under compression in fissure clothes or clothes. For forcing the clothes for the pumping to move out the top. Additionally, as the top opens to its natural state after the passing of the cam, restitution or release, fluid flow in induced to pump. Some common applications include pumping in fluids down an infusion device, aggressive chemicals, heat, salt, rolls, and other materials with insulation of the product from the environmental, and the environment from the product are critical. It is also used in hair-long machines to circulate blood during and bypass surgery, as the pump does not cause significant hemodialysis. For this application and the importance of the infusion pump, it is relevant to mention the precision with which it must deliver the mechanical for the best control and to avoid medical complications.
For the activation of our infusion pump, we define two programmable parameters for the user and a control of the beginning of the process. One of the programmable parameters is the time for the infusion and the second one is the volume. In our case, our volume range is from 23 to 43 millimeters per minute, and the control for the beginning of the process is a push button that allows the system to begin the process. Our infusion pump is controlled with a DC motor of 15 volts, which is controlled with PWM. In this way, we control the speed of our motor, therefore, we control the volume of the solution. To define the range of the volume, we characterize the volume that the motor was allowed to pump with each PWM signal. So, for a PWM of 190, we obtain 23 millimeters, and for a PWM of 255, we had 43 millimeters. We generate with Excel an equation that could calculate the correct PWM for a volume defined for the user between 23 and 43 millimeters. For the alarms, we use two optical barrier sensors. These ones are capable of detecting objects and in our case the variation between air and solution. This is very useful in the detection of air bubbles and when there is occlusion before the microdrip camera that could tell us that the solution is over or that there is an artifact that don't let the water flow through the camera. In this last one, the program has a condition and is that the alarm is only activated when this happens and the process is in progress. The way how the program activates the alarm is setting an umbral for each sensor. If the sensor's output past the umbral means that there is sensing air and no solution. which means that there is air bubbles or there is no solution during the infusion process. The circuit that we use for the infusion pump consists of the connection of each sensor and an electric power stage for the motor, because this one requires of 15 volts to work and to generate the enough force to impulse the water with the rollers through the hose. To achieve that, we use a TIP31C, which is a bipolar power transistor. In this one, we can see the rollers boost the water with the motor. The mechanism works with the rollers boosting the solution with different speeds. This causes the beginning of the microdrip, so if the speed increases, the microdrip too, and that is the reason why the flow increases proportionally with the PWM. In this video, we can see better the microdrip and a medium speed. Like the last video, in this one we can perceive a bigger speed. And in this last one we can see that when there is still water in the hose, the alarm is off. But when there is no more water and the process is still in progress, the alarm turns on, indicating a possible occlusion that in our case is the water depletion.